The first step to adding the left and right detectors is to modify the template. Right now we have an argument defined for the front mode pin, but we need one for the left mode and the right mode as well. Don't forget to put in what type of data it is. So here I have left on the left side, front in the middle, and right on the right side. I need to put them in the exact same order over here where I declare the sensor's object. So D1 is attached to the left sensor, and then D5 is attached to the right sensor in the same order. Once I've done that, I need to declare a couple variables to store this information. I'm going to make them private variables, which means they can only be seen from within this class. The first one is going to be called left ambient, and then we'll have front ambient. And this is just going to store the ambient light values that the sensors pick up. Down in the sense function, we're going to have to do something very similar to what we've already done to power the left sensor, which is pin mode left mode as an output, and then we're going to have to write it high to supply the power. Oops. And then to give it a little bit of time to take effect, we're going to delay for just 1 millisecond. We didn't have to do this in the past because the front mode pin was the only one that was set high, and we never turned it off. Once we've done this, we need to go ahead and collect some data. So I'm going to write left ambient. This is the variable we created to store information for the left sensor. And we're going to set it equal to analog read A0. That's similar to what we have down here in the view function. Once we've collected our data, we need to go ahead and turn that sensor off because that pin, the single analog pin that the Node MCU has, is being used by multiple sensors. So to turn the left sensor off, we say pin mode and then left mode input. We don't set it low. And the reason we don't set it low is because this prevents electricity from flowing back into the left mode pin, which if we set it low, that would not only mess up our readings, but probably burn out the pins involved. Now that we have this, it's time to go ahead and do something similar for that front sensor. So we'll give it a delay again to let that high value have time to take effect. Here we're going to say front ambient equals analog read. And then again we're going to turn the front sensor off by setting it as an input. Once we've done that, we need to modify our view function. Instead of reading directly from that analog pin now, we're going to read the values from the variables that we created here. So I'm going to make this one the front ambient, and then before that I'm going to put serial print, and I'm not going to do a print ln, I'm just going to do a print because I want these to show up on the same line. The ln creates what's called a carriage return character, so that in addition to printing this value, it takes the cursor to the next line. We don't want that when we're putting both of these sensor values in because we want to see them side by side so that we can distinguish them easy. Another thing we can do to help us distinguish these numbers easily is to put a tab stop in between them. If we didn't do this, then we would have two numbers printed right next to each other and we wouldn't know where one ends and the other starts. So by putting this /t in between these, we're giving it a tab space in between those. Once your code has finished uploading, open your serial monitor and press the button on your mouse. You should see two columns of data flowing past, and when I put my hand in front of the front sensor, that value goes down, and when I put my hand in front of the left sensor, that value goes down. I'll leave it as an exercise for you to add the code for your right sensor.